Now there are a few special cases which make significant differences. Firstly, when the feed line length is exactly half a wavelength, and I'm referring here when I say allow for speed, I'm referring to the electrical wavelength, which is dependent upon the velocity factor of the cable itself. For example, typical coax would have a velocity factor of about 0.66 C. So if you allow for that and calculate the electrical feed line length, if you've got exactly half a wavelength, then you will get the same value at the end of that half wavelength length of transmission line as the antenna impedance. So for example, if you've got a balanced transmission line with a characteristic impedance of 300 ohms and your antenna happens to be 75 minus 30J ohms, then basically you will have the impedance at the end will still be 75 minus 30J ohms. No transformation will take place. The impedance will be preserved. Now if the feed line, the other special case is if the feed line happens to be quarter of a wavelength, that is electrically speaking, then if you have a short circuit at one end of it, it is effectively an open circuit at the other end, and an open circuit at one end becomes a short circuit. So as a result you get very big impedance transformations when you have a transmission line that is quarter of a wavelength long. So the general advice is always to avoid odd multiples of quarter of a wavelength. So if you've got 1, 3, 5, 7, any odd numbered multiple of quarter of a wavelength should not be used. Now the other thing with impedance matching is you should use an antenna tuner with a roller bearing inductor. There are many very good antenna tuners that are used with amateur radio equipment that are switched from one band to another, and the switch basically puts a different tap on the inductor, and then there's a couple of capacitors usually in most of these pi tuned circuits or L tuned circuits to allow you to tune the antenna. The problem with a switched inductor is that you've only got certain values of inductance that you're switching to, and for M.A.R.S frequencies that are outside the normal range that are used in amateur circles, then you need to have an ability to tune over a much wider range, and you'll find that a roller bearing inductor which can be continuously changed to the actual contact point will give you much more flexibility in terms of being able to tune your antenna to operate on particular M.A.R.S frequencies. Now let's have a look at linear amplifiers. How do we get them to tune to M.A.R.S frequencies? Well, some are actually very easy to convert, some are difficult. Sometimes it's a question of the electrical circuitry, sometimes it's a question of the physical size within the item and difficulty of getting access to the appropriate elements. Now two separate items really need to be looked at. One is the input filter itself, that is the input filter that looks at does the impedance matching between the transceiver and the valve or transistor stages within the amplifier, and also does some filtering to basically prevent harmonics from being taken into the main amplification circuit and being amplified and sent out. Now if the input filter can't be tuned, you've got to look at it and say, well, can you tune it to an appropriate range to allow for the M.A.R.S frequencies. Now the other item is the tank circuit, that is the circuit that's on the main antenna side of the power amplifier, that is basically used to filter out unneeded frequencies and give reasonable tuning, and to also, usually the Q on most tank circuits is about 13, 14, and there are some variations but not much. And that gives you quite a good way of eliminating harmonics. Now the difficulty is, can the tank circuit be tuned across wide enough a range to allow you to make use of the appropriate M.A.R.S frequencies that will be outside maybe your 80 meter amateur band. Now typically if you're talking about a M.A.R.S frequency that is within 5% of any amateur frequency, it's pretty easy to actually accommodate that frequency by simply just tuning things, and everything will work fairly straightforwardly. If the M.A.R.S frequency is 10% or more, then you usually need to do some form of adjustment, either on the input filter or on the tank circuit. So let's have a look at what can be involved with such alterations. For example, here's a case of an AL80B, a well-known amplifier, and this one, what we needed to do is to get it to work to a much lower frequency. Instead of working at in the 3.5 to 4 meg range for the amateur band at the 75 to 80 meters, we needed to get it to work at a much lower frequency down at 92 meters. Now, I'm only mentioning approximate frequencies here because this is a publicly recorded video, so we're not talking about specifics, but if we look at a particular idea, what we're trying to see is, can we get this amplifier to work over a much wider range? Now in this particular case, the input filter, which is a bandpass input filter, was quite workable. It could be tuned across to be reasonably acceptable for getting a good impedance match for the input side of the circuit. However, the tank circuit was not acceptable. No matter how we tuned it, we were only able to get 200 watts peak output, which, considering you'd be putting up to 100 watts in, seems to be something wrong, and that of course is not a good way to operate the amplifier. Now when we looked at the schematics, I found that the 3.4 megs to 4.2 megs was actually typical of what that amplifier could actually handle. What was needed was to put a new tap on the HF tank coil, and basically by taking a ratio of turns to frequencies of number of turns, ratio of turns in terms of the inverse relationship between the frequencies, then it was quite easy to put a new tap a few turns down that would enable the band position to basically work from 3.2 megs all the way up to 4 megs. So we didn't actually lose capability of communicating on the regular amateur bands, but we gained the capability of operating much lower, all the way down to 3.2 megahertz, which included the 92 meter band that we were interested in working with. Now if we look at other aspects of M.A.R.S operation, one important aspect is digital systems. Now, passing traffic such as EI reports accurately is one of the main reasons for why we use digital. Now you might be thinking, well, what about CW? Well, CW was introduced back to M.A.R.S in 2008 after many years of not being used within the military circles. It has been reintroduced as an effective means of getting data across in circumstances when a power failure can occur in emergency situations and computers may run out of additional battery resources, and sometimes that is a reasonable way of getting traffic across.